This chapter concerns with the method of duality or dualistic methods. In the previous chapters, we introduced with the deterministic methods as graphical and simplex method, which is known among scientists as primal table or primal problems. So the linear programming problem has two options: the primal problem and its dualistic phase. Each primal problem of linear programming has its dualistic side. Now, let us remember LPP or linear programming problem deals with how to maximize profit or to minimize cost. The objective function has two forms: maximization or minimization. These two objective functions has dualistic side. So we can convert the objective function of maximization to objective function of minimization in the dualistic option. Also, we can convert the objective function of minimization to the objective function of maximization in its dualistic version. So, the main idea of duality is each linear programming problem has two sides: the primal one and the dualistic one. If the primal is about maximization, then its dualistic is about minimization, respectively. If the primal is about minimization, so its dualistic option is about maximization. Now, so why we need to apply this method? The importance of this method, it helps us in understanding some important classes of linear programming. These dualistic methods can help us in understanding methods like transportation simplex, Hungarian algorithms, and the network simplex methods. So, also the duality can be very useful in understanding the sensitivity analysis. Sometimes, to find the visible solution, initial visible solution to the dual is much easier than finding one for the primal. Dual variables give the shadow prices for the primal constraint. Sometimes the dual is just easier to solve compared with the primal one. Now, so the main question is how to convert the primal simplex methods, the primal linear programming to its dual version or dualistic version. This is the main function, and it has very significant advantages in the process of optimization the scarce resources. The dualistic methods plays very significant role in understanding and solving the problem of optimizations the scarce resources, whatever we are talking about, the problem of transportation or the problem of assignments, of network, project scheduling, etc. So, now we are going to ground the landscape to fix the essence of this problem. Scope and aspects. Every linear programming problem is associated with another unique linear programming problem or problems. The original or given problem or the given problem is then called the primal problem. المشكلة الأساسية. Otherwise, المشكلة الابتدائية. احنا عندما نتحدث عن الحل الأساسي والحل الثنائي، by the way the dualistic methods، الحل الثنائي أو المقابل face to face، each حل أساسي has each حل مقابل، each problem أساسية has its مشكلة المقابلة لها. That's what do we mean by dualistic, primal and duality. نموذج أساسي والنموذج المقابل أو النموذج الثنائي. So linear programming problem is associated with two unique models. From one hand, the given one, which is known as primal problem. On the other hand, the problem which is converted from the original one, which is known as dualistic methods or dual problem. So the relationship between the solution of a primal and its dual proves to be extremely useful in a variety of ways. So we can solve the primal problem, for example, using the simplex methods and record the results. For example, S1 equal, S2 equal, X1 equal, X2 equal, etc. Assuming the problem of maximization using the simplex methods to optimal or to find the optimal solution. So the problem of maximization should be converted to the problem of minimization in a dualistic form. So the dual problem about how to minimize cost, while the primal one, it was how to maximize profit. Our challenge to find the common factors between these two solutions. For every linear programming problem, there is a corresponding follow. Each primal problem is followed by dual one. So for every linear programming problem, there is a corresponding unique problem involving the same data and describes the original problem. The two programs has very closely related and optimal solution of dual gives complete information about optimal solution of the primal and vice versa. Let me break down this statement. The problem of minimization in a dualistic form gives full information and data about what the primal, its primal version. Let's move to the main station. Conversion of primal to dual. Remark. How? So now we are going to follow how to convert primal to dual. It is not necessary that the primal is to be maximized. It can be also minimized. Don't associate the problem of conversion with the objective function of maximization only. It can be also a problem of minimization, which is required to be converted to maximization side. Now let's follow the steps of conversion. First, the maximization problem in the primal becomes minimization in the dual, and vice versa. مشاكل التعظيم في النموذج الأساسي أو الأصلي تتحول إلى مشكلة تدني التكاليف في النموذج المقابل، والعكس. إذا كانت مشكلة البرمجة الخطية الأساسية هي مشكلة تدني التكاليف، ستتحول في النموذج المقابل إلى مشكلة تعظيم ربح. If the primal problem is about maximization profit, then in its dual option it becomes problem of minimization, and vice versa, So convert maximization to minimization, or convert minimization to maximization. Step 2. We know that the maximization problem has less or equal to type of constraints. نعلم جيدا أن القيود في مشاكل التعظيم هي أقل من أو يساوي. We know that the constraints of maximization problem usually less or equal B1. B1 stands for resources, while in the minimization version the constraints usually are greater or equal, more or equal type of constraints. Number 3. If the primal contains M constraints, and n variables, check, put into account. The primal has m constraints and n variables, decision variables. Then the dual will contain n constraints and m variables. D'accord. So if the primal has two constraints and two variables, no, let it be like that. If the primal contains three constraints and two variables, then a dualistic sides will contain what? Remind, three constraints and two variables. The primal will contain what? Two constraints and three variables. Three constraints, two variables. In dual it will be like that, two constraints and three variables. Step 4. The constants C1, C2 up to Cn, which mentioned as easier profit of 1 unit when we are talking about maximization, and cost of 1 unit when the objective function deals with the problem of minimization. Now, these constants C1, C2 up to Cn in the objective functions of primal, usually these constants are replaced where? The objective function C1 and Cn are the coefficients of decisions variable، هم معاملات متغيرات القرار في دالة الهدف. بتظهر لنا وين؟ appear in the right hand side of constraints of the dual، اللي هي B1 B2 B3 or Bn. This C1 up to Cn will be pushed to the right sides of constraint as resources. Now, so step 5 states that B1, B2 up to Bn in the primal option will be moved to the constants of the dual option. B1, B2 up to Bn are resources. When we see more or equal B1 or less or equal B1, these are usually replaced in the right side of constraint. Okay. Now, maximization to minimization and vice versa. C1 up to Cn in the primal will be pushed to B1, Bn in the dual. B1 up to Bn in the primal will be C1 Cn in the dual, and that's correct. Okay, please, as usual, collect your pen and paper and follow the steps of conversion. Now, constraint, objective function, constraints, non-negativity condition, etc. Please focus on the left side of this slide. Primal problem. The right side is duology. Now, the objective function in the primal problem is about maximization. So C1 x1 plus C2 x2 plus up to Cn xn. This is an objective function of profit maximization, where C1, C2, Cn are profit of 1 unit of what? 1 unit of product x1, x2 and xn. x1, x2, xn are decision variables. Subject to satisfy the application or the satisfaction of this objective function is restricted by what? Subject to the first constraint a11 x1 plus a12 x2 plus up to a1n xn less or equal b1. So, this LPP, linear programming problem, has m constraints, and each constraint represents one phase of the production process. Every constraint contains of the cost of producing 1 unit, for example, for x1 and for x2 at the first phase step. The right side constants b1, b2, bm are resources. We mentioned before the constraints of maximization is less or equal resources. logically. The last component is x1, x2 up to xn. The product x1, product x2, product xn should be more or equal 0 objectively. Now we are going to convert the primal to the right side of dual. Maximization should be converted into what? Minimization, W. So, now C1, C2 and Cn should be removed to what? To be replaced instead of profit of 1 unit should be pushed to the right side of constraints as B1, B2, Bn. Check C1, C2, Cn in the dual at the right side of the constraints. The coefficient of the dual are what? Are the resources, the constants of the right side of constraints of the primal one. طيب إذن نلاحظ أن دالة التعظيم تحولت إلى دالة تدنئة. هي ماكس زد تحولت إلى ماين دبليو. معاملات القرارات اللي هي عبارة عن ثوابت الموارد المتاحة في القيود. هي B1 تحولت للغاية واي، تحولت كمعامل لبرودكت Y1، وB2 تحولت كمعامل للبرودكت Y2 etc. وBN تحولت لمعامل للسلعة أو البرودكت YN. ثانيا إذن هذه هي the components of the objective function of the dual. Y instead of X, B1, B2, Bn instead of C1, C2, Cn. Z, W instead of Z, Y instead of X, and B1 instead of C1. D'accord. Let's move to the contents of the constraints. The constraints in the dual are designed from the vertical of the constraints of the primal. Just get the constraint of the dual, the first constraint of the dual are the first column of the constraint in the primal. A11 x1, check, instead of x we said y, and A21 y2. So we remove the first column of constraints of primal to the first row of the constraints of dual, respectively. The second column of the constraint of the primal will be removed as the second row of constraints of the dual, etc. The non-negativity condition x1, x2 up to xn will be replaced by y1, y2 up to yn more or equal 0 objectively. Now, last remark, the constraint, the inequality of the constraint or the sign of inequality of primal will be removed from less or equal to greater or equal, as mentioned before. The constraints of minimization all time are more or equal, but the constraint of maximization all time is less or equal. This is the theoretical approach to understand how to convert, how to create the dualistic version of primal 1. Very easy. Just try to follow the instructions using your equipment, pen, whatever, paper, pencil, sheet, etc. Okay. Convert the following primal linear programming problem to the dual. Just follow the previous step. Now, the primal is about profit maximization. The components of this primal: objective function of profit maximization, and it contains two variables, x1 decision variables, x1 and x2. The profit of one unit of x1 equal 5, and the profit of one unit of x2 equal 3. The objective function is restricted by 3 constraints, and obviously the non-negativity condition is given. Now, the requirement is to remove this primal to the dual one. Now, let's see. If the variables equal to, if the variable equal to, here we have two decision variables, x1 and x2. then the constraints of the dual will equal 2. So the constraint in the dual equal the variables in the primal or in the objective function. D'accord? D'accord. Now, the objective function of the dual should contain 3 coefficients. Why? Because the primal has 3 constraints, and the constants of these constraints, I mean by the constants b1, b2, the constants of the right side of the primal constraints, there are 3 constraints, respectively 3 constants, resources. These 3 constants will be the coefficients of the objective function of the dual. Then, once like that, the objective function of the dual will consist 3 decision variables, and the coefficients of this variable will be the constants of the constraints on the right side of constraints. 2y1, 2, as you see, is the constant on the right side of constraint number 1. 10y2, 10 is the b2 or the constant or resources of the second constraint of the primal. The last is 12. 12y3. What 12? 12 is the p3. Is the p3. Now it removed to be a coefficient of the y3. Now let's move to the how to design a constraint of the dual. Firstly, once we have 2 columns of the constraints of the primal, then each column of the constraints will be removed to be as a row of constraints. Now, the column of the constraints of the primal is x1, 5x1 and 3x1. The second column contains x2, 2x2 and 8x3. We'll check it. Sorry, 8x2. Then the first row of the constraints of the dual will be like y1, y1, because the coefficient of x1 is 1, respectively the first figure of this row is y1, then 5y2, then 3 y3. 3y3. The second row of the constraint of the dual will be y1 plus 2y2 plus 8y3. The first constraint is more or equal 5. What is 5? 5 is C1 in the primal. The second constraint is more or equal 3. What 3? 3 is the C2 in the objective function of maximization. x1, x2 more or equal 0. Then in the dual we have 3 variables, y1, y2, y3. All of them will be more or equal 0. The last remark is, look to the dual. The objective function has 3 variables because the primal has 3 constraints. The dual version has 2 constraints because the primal has 2 variables. The coefficients of variables of the dual are the constants of the constraints from the primal. Okay. The constraints of the dual are designed as what? As each row of the constraint of the dual represent the column of the primal. Respectively, once we have 2 columns in the constraint of the primal, then we have 2 constraints or 2 rows of constraints of the dual. I think this is very clear. Very clear. Just focus and follow the instructions and steps. This is very easy and very attractive as well as exciting, very exciting. Okay, example 2. Given primal as linear programming problem of minimization, we need to convert this primal problem to the dual one. Okay. The components of the primal are usually objective function, main W is about minimization, objective function consists of three variables y1, y2 and y3. The decision variable of these objective functions are 3: y1, y2, y3. The coefficients of these decisions or decision variables are 2 the cost of 1 unit of y1, 10 is the cost of 1 unit of y2, and 12 is the cost of 1 unit of y3. Also, given two constraints, y1 5 plus 5 y2 plus 3 y3 greater or more than 5. The second constraint, y1 plus 2 y2 plus 8 y3 more or equal 3. Now, once we have 3 decision variables, then the non-negativity condition represents these 3 decision variables or variables y1, y2, y3, should be more or equal 0. Our duty is to remove the primal problem to the dual one. Again, let's remember the instructions or the step of conversion. First, minimization becomes maximization. W becomes Z. Y becomes X. Right. The variable of the dual should equal the constraints of the primal. The primal gives 2 constraints, then the dual will consist 2 variables. It will be x1 and x2. The parameters or coefficients of the objective function will be the constants of the constraints of the primal. 5 will be the coefficient of x1, 3 will be the coefficient of x2. Then the objective function of the dual will take the following equation: max z equals to 5x1 plus 3x2. Let's step forward. to design the constraints of the dual. The numbers of the constraint in the dual or of the dual equals to the number of variables in the primal. The primal has 3 variables, y1, y2, y3. Then respectively the dual will contain 3 constraints. The first column of the constraints of the dual is the first row of the primal, and the second column of the dual represents the second row of the constraints of the primal, or the first constraint in the dual is the first column in the primal. The second constraint represents the second column in the primal. The last row of constraint in the dual represent the last column of constraints in the primal. Now, as we mentioned, the constraints of maximization all time is less or equal. Constraint number 1, x1 plus x2 less or equal what? Equal the coefficient of y1, which is 2. The second constraint, 5x1 plus 2x2 less than or equal 10. What is 10? 10 stands behind what? The coefficient of the second variable. 10 is the coefficient of y2. 12, 3x1 plus 8x2 less or equal 12. What 12? 12 is the parameter of what? Of the variable y3. Then 3 constraints equals 3 variables in primal. Two variables in the dual equal 2 constraints in the primal. Okay. Now, the variables in the dual are y1, y2, y3 more or equal 0. The variables in the dual are 2 only, x1, x2 more or equal 0. Please, actually the primal problem in example 2 was the dual in example 1. Please step back to the example 1. You will find that we removed the dual option in example 1 to the primal problem in the example 2. We can play with this game as long as we need. Now, so how to the conversion of minimization to maximization, and the conversion of maximization to minimization. This is very easy and very excited practices. We will go deep to explain and identify the features of this problem. Okay. Example 3. Primal given as minimization. Mind W equal 4y1 plus y2. Objective function. 4 stands for a cost of 1 unit of y1. 1 is the cost of 1 unit of y2. The constraints are 3y1 plus y2 equal 3. 4y1 plus 3y2 more or equal 6. y1 plus 2y2 less or equal 3. Now, please check the 3 constraints. The first one is equation. Is an equation 3y1 plus y2 equal 3. The second constraint 4y1 plus 3y2 more or equal 6. Respectable. y1 plus y2 less or equal 2. One of these constraints is suitable to the problem of minimization, which is 4y1 plus 3y2 more or equal 6. But we face problem with the constraint number 1 and constraint number 2. The constraints of 1 should be inequality. Easier, less or equal, or more or equal. Now, let's first fix the constraint number 1. We assume that the constraint number 1 may more or equal or less or equal. So we are going to divide this equation into 2 inequalities. 3y1 plus y2 more or equal 3. Very good. This is suitable to minimization. But 3y1 plus y2 less than 3 is not suitable to the problem of minimization. So how to make it suitable. By what? By multiplying this inequality by -1. So it will be negative 3y1 negative y2 more or equal negative 3. So then the first constraint and the second constraint, both of them are more or equal. So we created from the constraints 1 two constraints. Both of them are more or equal, but one with the negative sign. The second constraint is suitable, but the third one is not suitable. So then should be multiplied by -1. Then negative y1 negative 2y2 more or equal what? 3. Now we have four constraints. 3y1 plus y2 more or equal 3. Negative 3y1 minus negative y2 more or equal negative 3. 4y1 plus 3y2 more or equal 6. Negative y1 negative 2y2 more or equal 3. Four constraints gotten. Notice that the constraints of maximization is greater or equal, but the example shows the different constraints, so we need to adjust all constraints to greater or equal first, and then to fix the objective function as stated above. Now we will deal with the function of minimization min w equal 4y1 plus y2, and with what? 4 constraints and non-negativity condition. First, the expectation of the dual problem. So minimization becomes maximization. The variable of maximization will be 4, equals to the numbers of constraints of the primal. Primal has 4 constraints. Then the variables of the dual should be 4: x1, x2, x3, x4. Okay. The constraints of the dual of maximization becomes 2, because the primal has 2 variables. Then the constraints of the dual will be 2 only. The constant of the dual will be 4 and 2, but the coefficients of the dual will be 3, -3, 6 and 3. Okay. So how to redesign the problem of the dual if the constraints given like an equation or different inequality. Now let's develop this version in the next step. The term dual in general sense implies two or double. In the context of linear programming, duality implies that each LPP can be analyzed in two different ways but having equivalent solution. Moreover, whenever the LPP contains a large number of constraints and a smaller number of variables, then the level of computational can be considerably reduced by converting it into the dual and then solve it. Every LPP is associated with another LPP called the dual based on the same data. The original problem is called the primal, while the other problem is dual. That means each linear programming problem has two phases, primal and dual. So the primal, each primal problem can be converted into dual, and the dualistic can be converted into the primalistic version. So each LPP has two options, primal, and this is an essential, and the second the dual or the dualistic option. Okay, let us follow the steps of formulating the dualistic LPP. Let the primal LPP be given. Max or maximization, max z equals c1 x1 plus c2 x2 plus up to cn xn. C1, C2 and Cn in case of maximization refer to the profit of 1 unit of x1, x2, xn. X, from other hand, x1, x2, xn refer to the decision variables between brackets, for example products. This subjective function is subject to the following constraints. A11 x1 plus A12 x2 plus up to A1n xn less or equal B1. A11 is the cost of 1 unit of x1. is the cost of production 1 unit of x1. A12 is the production cost of producing or 1 unit of x2. A1n respectively, it is the cost of producing 1 unit of xn. B1 is constant. It indicates available resources, the company, and so on. The non-negativity condition is x1, x2, xn more or equal 0. So our target now is to create a duality version to the primal table. So let us take the process of formulation of dualistic LPP. Now I'm going to discover the corresponding dual is defined as, check please and pay attention. The problem of maximization became problem of minimization. The problem of maximization became a problem of minimization. Instead of maximization, the objective function should be replaced by minimization. So min z, we can say that min z or min y. It makes no sense here. Now, as you remember, B1, B2, Bm, whatever, they were a constant at the right side of the constraints of the problem of maximization. Now, the coefficient of the dual objective function, the coefficient of the dual objective function is a constant of the prime of the objective function of primal problem. So max to mind, the objective x to y, you can say that instead of x you can replace y. The coefficient of the decision variables for minimization are the constants or solution of the problem of maximization or the primal option. Okay. subject to the constraint for the dual option should be designed vertically from the constraints of the primal. So the first column of the primal converted into the upper constraint of the dual, and the second column of the primal should be the second row of the dual. The constant of this constraint, or the constant of the dual, or the solutions or the resources of the dual, the constraints of dual, are the coefficients of the objective function of the primal. That's why a11 y1 plus a12 y2 up to a1n ym equal c1 c2 up to cn. As you remember, c1 c2 cn were the coefficients of the decisions variable or primal option or primal problem. Constantly, the non-negativity condition is more or equal 0, obviously. So this is the shape of the dualistic option of primal LPP.